Hey everybody, welcome back to the third part in our series on partitioning, also called dividing line segments. So in this example, we're going to end up with an answer that has fractions and mixed numbers. So I wanted to show you the best way to go about doing it. So this example says, given that AB is 5 times longer than BC on the directed segment AC, where is B? So if you remember, the very first thing that you want to do with a problem like this, other than graphing it, and this one is graphed for us, is to make your dash diagram. Getting the dash diagram correct is essential to you solving the entire problem. So if you feel like you're still struggling with dash diagrams, I'd recommend checking out the first video that I did on this, where I did a few different examples of dash diagrams. So right here, this is the part we need to make our dash diagram. The dash diagram comes from the part where they're comparing the two segments. So in this case, it says AB is 5 times longer than BC. Typically, the best way to do that is just to take whichever side they said was longer and make that however many times longer it is, that's how many dashes you want to use, and then you'll just use one dash for the remaining section. So in this case, from A to B, we'll have 1, 2, 3, 4, 5 dashes, and then the remaining part for the whole segment AC will be 1 dash. And so you can tell that AB is 5 times longer than BC, because BC is just 1, and AB is 5. The next thing you want to do is you want to write your part to whole ratio. And pretty much for every problem that I've seen, the best way to do this is to use the first part, since we're always going to be going from the starting point. So we want to use the first part of our line segment and then the whole thing. So the first part is 5. And then the whole thing, including BC, is 6. The rest of it is just plugging it into the formula or graphing it all out. So whenever your answer is going to end up having fractional answers, I personally find it a lot easier to just do the formula, but I will show you how to graph it. And to show you how I knew that this was going to end up with fractional answers, whenever I checked the slope here, I ended up with 1, 2, 3, 4, 5 on that side, and over here 1, 2, 3, 4, 5, 6, 7, 8 on that side. And since 5 and 8 aren't going to reduce to any lovely slope that would be reducible, it's not like I can count out slope steps here, I know my answer is just going to be a little bit sticky. The other thing that you're going to want to do, remember, is to label the starting point. I mean, it's nice with the dash diagram because you kind of go from start to finish on the dash diagram, but especially for those of you who are going to be graphing the answer, make sure you label start and end, because typically, if we typically read, from left to right, we might be tempted to say that this is the starting point and just kind of work from left to right, but we want to make sure it's based on the name of the segment. So the name of the segment, the first letter is the starting point, and the second letter is the ending point. So I'm going to write my formula. Remember, the formula is going to be x1 plus the part over whole ratio times x2 minus x1. And sometimes I feel like maybe you have trouble remembering formulas. What's really nice is this x2 minus x1 shows up in a lot of different formulas. I mean, it is the distance between the x's, so it shows up in the distance formula. It also shows up in the point slope form of a linear equation. So seeing that minus, if you forget, oh, is there a minus there or not, hopefully, you can recall from some of the other formulas that it does have a subtraction sign there. And then we'll do the same thing with the y's. I'm going to go ahead and work the x's out first, and I'll go back and see where the y's end up. Oh, also for this one, they didn't actually give us the coordinates, so we have to count to figure them out. So A is at 1, 2, 3, 4, 5, -1. And C is at -1, -2, -3, 1, 2, 3, 4. I always find it helpful to label the points x1, y1. Make sure your starting point is x1, y1. Make sure your ending value is x2, y2. That's going to be the most important thing as you put things into this formula. If you mess up on the x1 or x2, you're going to get the answer wrong. So a nice check that I like to do is because x1 comes at the beginning and at the end of the formula, I like to plug it in both places at once. That way I don't forget. And then the part over whole ratio is going to be 5/6, and x2 is -3. So here I have 5 plus 5/6 times -8. And when I work that out, I'm going to get 5. So a positive times a negative is just a negative, and 5 times 8 is 40/6. Remember, whenever you're multiplying a fraction by a whole number, you only need to multiply the numerator with the whole number and keep the denominator the same. At this point, you could just put this answer into your calculator, as long as you're willing to do some guesswork on how to convert the repeating decimal that you're going to get into a mixed number or into a fraction. Currently, the Khan Academy answers are set up. Most of them are set up in mixed number form, so I'll show you how to do that in a moment. If you wanted to work this out completely by hand, we just need to give 5 the denominator of 6, so the number that 5 would turn into is the product of 5 and 6. So I'm going to turn that into 30/6 minus 40/6, because 30 divided by 6 is 5. And that gives us -10/6, which is, if I wrote that as a mixed number, that would be -1 4/6, which would reduce to -1 2/3. So that's going to be my x answer. If you did put this in a calculator, you would get -1.66667. And it's kind of handy, well, the 7 is because the calculator rounds for you. It's kind of handy to know that this decimal, 0.66667, is the fraction 2/3. So that's how we get -1 2/3 if you just put that in your calculator and needed to change it over. Next, I'm going to try the same thing with the y's. I guess I'll try to write it nice and small here. So y1 plus part over whole times y2 minus y1. So y1 is going to be -1. Like I said, I like to plug that in both of them at the same time. That way I don't make a mistake and forget. Also, the subtraction sign from the formula comes down, and even though we have a -1 as y1, I like to put the double subtraction signs first, even though I know it's going to convert to a plus sign, just so I don't do too much in my head. I like to see it all written out. And then that's 4 for y2, and part over whole is still 5/6. So if I keep working that out, -1, let's see, this is going to turn into a positive 5. And so 5 times 5 is 25/6. Remember, this is 5, and I only have to multiply the whole number times the numerator. Over here, I could convert the number 1 into a fraction that has 6 as the denominator, so I would multiply it by 6. So that's going to turn into -6/6 plus 25/6, which is going to give me 19/6. So I have 19/6 as my improper fraction. And then if I wanted to turn that into a mixed number, 6 goes into 19 3 times with one little guy left over. So it would be 3 1/6. So that's going to be my answer for B. And then if you wanted to know kind of where it would be placed, you can kind of take this A to C dash diagram. You're going to have to spin it around so the A lines up with the A and the C lines up with the C. But you're going to have B kind of a lot closer to C over here. And if you checked that on our x-axis, -1 2/3 is going to be -1 2/3. That's going to be about here. And then 3 1/6 is going to be, coming over here. So you're going to get this value for B. So the final answer is going to be that B is at -1 2/3. and 3 1/6. Oh, you might not be able to see that 3 1/6. I might have written off the edge of the board, sorry. So b is -1 2/3 and 3 1/6. That's better. All right, oh, sorry. If you had put this into the calculator, -1 plus 25/6, as a decimal, that's going to give you 3.1666667. Like I said, the calculator rounds it to the 7 for you, but just 0.66667 is 2/3. 0.16667 is 1/6. So I think it's handy to have a few of those repeating decimals memorized, just so you can use a calculator and you don't have to do too much of this. I'll put in the description bar what some of them are, some of the other common ones. And you really are only going to need those repeating decimal conversions whenever your whole value is out of 6 or maybe 3 or 9. Remember, when you're dividing by 2 or 4 or 5, you're typically going to end up with a nice terminating decimal for your answer. I did say I would talk to you about how you can do this on a graph. And the way you would do that is by taking these distances, the 5 and the 8, and you would actually be multiplying those by the part-to-whole ratio. So if you multiply 5/6 by that part-to-whole ratio, you're going to get 25/6, which is 4 1/6. And if you multiply 8 by 5/6, you're going to get 40/6, which is 6 4/6, which is 6 2/3. Now what you're going to have to do, so it would be a little bit easier because you're not doing this entire formula, but you're just doing the formula graphically. So you're multiplying the distance, which is what you got when you subtracted the x's, like the x's turned into -8, and that was the 8 from there. When you got the distance between the y's, that was 5. And you're just multiplying the distances by the part-to-whole ratio. Then it's up to you to go back to the starting point and count it all out. And sometimes that can be frustrating because you're counting these fractional parts on a line, on a number line. So if I started 4 1/6, so that means I need to travel 4 1/6 toward C. Now that was of my 5, which was the vertical distance. So I would start in line with the starting point, and I would go up 1, 2, 3, 4, and a 6th. So I have to say it all out loud to myself. So I'm going from -1, 0, 1, 2, 3, and a 6th. And that's where my answer is going to be, 3 1/6 for my y coordinate. And then for the x coordinate, you're starting over here on A, and you're going to the left 6 2/3. So I'm going to go over from 5, 1, 2, 3, 4, 5, 6, and 2/3. So you were at -1, and then you did 2/3 more, so it is -1 2/3. So in this case, it was kind of easy because I ended up almost at the value, the fractional value. I wasn't working in reverse, but sometimes it can be a little trickier than that. So I know that these are somewhat complicated problems, especially when fractions get involved, but hopefully you can focus on these formulas and making your dash diagram, and it should all work out for you as long as you're careful with signs and everything like that. So good luck, and I'll see you guys soon.